In this chapter, we're going to look at the concept of complex numbers. In order to discuss these, we first need to look at what's meant by an imaginary number. To begin this discussion, consider the square root of -1. If you try this on your calculator, you'll probably get a math error. We know that if we multiply -1 by -1, we get 1. And if we multiply 1 by 1, we also get 1. So the square root of 1 is either -1 or 1. But how could we get -1? We could do -1 times 1, which gives us -1, but then these two numbers are different, and the definition of a square root says that it's a number which multiplied by itself gives the number we're interested in. -1 and 1 are different numbers. So clearly we can't find two numbers which are the same, which multiply to give us -1. What we do is we say that the square root of -1 is an imaginary number which we call I. We can consider a few features of I. I squared would be -1. If I is the square root of -1, then I squared would be -1. The square root of -4, using our knowledge of surds, would be the square root of -1 times the square root of 4. And root 4 is 2, root -1 is I. So the square root of -4 is 2i. We can now return and look at the definition of a complex number. A complex number is a number z of the form a plus ib, where both a and b are real numbers. Looking at z, we can see a, which is a real number, is a real part of this number. ib, a real number times I, is the imaginary part of this number. So a complex number z is a number which is part real and part imaginary. For example, we could have z is equal to 4, take away 2i. It's worth noting that real numbers are complex numbers where the imaginary part is 0, and that imaginary numbers are complex numbers where the real part is 0. If z is equal to a plus ib, we define its conjugate, which is usually called z star, to be a minus ib. Note, for the conjugate, the real part is the same, and the imaginary part has a different sign.